Please confirm you can see my screen. Whenever you see it, let me know, please.
Yes, we can, but it's not on the full mode, full view mode.
Okay, I want to do this.
Yeah.
So please confirm it's on the full screen mode.
Yes, it is. Thank you.
Okay. So, ladies and gentlemen, this is my pleasure. My name is Madu Abuchiogu, subsurface workflow analyst with Renaissance Africa Energy Company, and I'll be your moderator for this session. Today, we'll be talking about Seismic-to-Well Tie application and its common pitfall. And we'll be, in fact, like the publicity secretary has spoken, we flew in Mr. Felix Oluyemi, who is the senior geoscientist from Asharami Energy, all the way for this particular session. I mean, isn't this wonderful? A round of applause for Asharami Energy, a round of applause for NAPYP for this innovative idea. I mean, it's not easy to bring an expert, take him away from his rest and from his bed by this time of the morning. So, I don't know if our NAPYP lead is still here. If he's here, I think we'll begin by having the opening remarks. So, Mr. Sheun, if you're on board with us, please unmute yourself and let's have the opening remarks.
All right. Thank you very much, Madu Abuchi. Confirm that you can hear me.
Yes, you are loud and clear. I can hear you.
All right. Thank you very much. Good morning. Good day. Depends on what part of the world you are in. I want to, at this point, welcome you all to this June technical series. On behalf of the executives of the NAPE Young Professionals, I want to say a big thank you to our speaker, Mr. Felix Oluyemi, a seasoned geoscientist, someone who's very passionate about impacting the young professionals and students. Thank you for choosing to share this knowledge with us. A very important tool, a very important topic, like the moderator has shared and also the publicity secretary has shared as well. Thank you to all of you that have joined, and as has been mentioned earlier as well, if you know anybody that can benefit from this, again, as a professional association, these are avenues where we'll continue to equip ourselves with the necessary knowledge for our development. On behalf of the executives and the organizing committee for this June technical series, I want to say a big welcome to all of each and every one of you on the call. Thank you for also creating time to participate and then gain one or two knowledge. I believe that the topic for today, like I said, is a very crucial part of our job as explorationists. And I would say that you should get out your notes and your pens, because there'll be a lot to learn from today. Thank you very much, and I'll hand over to the head of the technical committee for NAPYP, who would give us an opening remark.
All right. Thank you very much, Sheun. Good morning to the NAPYP lead, Sheun, and our esteemed facilitator for today's meeting, and good morning to the entire team on the call. You are all welcome to the meeting today. As you all know, so far so good. As a technical team, we've been bringing very robust and technical topics and seasoned facilitators to handle those sessions. So for today, we're going to be looking at Seismic-to-Well Tie. So for me, I've been with NNPC for some years, and for the most part of my career with NNPC, I've been a seismic interpreter, and I know how important this aspect is. Seismic-to-Well Tie is one of, if I'm not mistaken, one of the most subjective areas of interpretations. So it's very good to have a proper foundation on this, because it's just going to determine um, the outcome of your interpretation. Fine, you have to do your faults and all of that. But before you start interpreting your horizon, you need to have a proper well to seismic tie, because you want to relate the information on your well tops that you want to carry across your whole field or the whole block. You want to relate it from the well to the seismic so that you can come up with your maps. And if you get this wrong, then trust me, you're going to interpret the wrong loops and all of that. So that is why we deemed it fit to bring our very seasoned facilitator for today. We know this may not, we may not be able to go extremely deep into the topic, but at least it's going to be a foundation. And I believe that it's also going to be available for a little chat, maybe if you have further questions after the meeting. So I will urge you guys to pay attention. And even me too, I'm going to get my pen and paper, because I also want to see a different perspective, to Seismic-to-Well Tie. So thank you very much, everyone, for joining, and I hope we're going to have a very fruitful and impactful meeting today. Yeah, thank you very much, everyone. Go ahead, Madabuchi.
Thank you, my lead. Thank you, everybody, for joining. Like the lead has spoken, Seismic-to-Well Tie is very, 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 very important. Very, very important. And it's like I said, the perspective in which you see it will determine. Yes, it's going to really, really determine. So I'd like to move into the safety brief. Now, I want us to all to be informed that this recording is going to be recorded. So please, you can avoid sharing any form of personal or sensitive information. And all participants here are supposed to and should mute themselves to avoid bringing in noise into the presentation, so as to avoid distracting our facilitator and also our listeners and learners. And as well, we are very, very big on respect. Very, very big on respect. So please let us address everybody, including the chat, as respectful as you can. Ensure to comment, ensure to ask your relevant question, and your questions will be taken after the presentation. Please, no harassment, no offensive languages, and let us avoid spamming this group. So by virtue of online sensitivity, please do not click on any suspicious link in the chat if it's not shared by anyone, maybe the NAPYP lead, the technical lead, the publicity secretary. Please do not click on it except you are being asked from here to do that. So we also want everybody to be aware of their environment. Wherever you are, please ensure you have the full concentration of whatever you are doing. And I believe by full concentration of what you are doing, I believe is this session. So if you are driving, so please, if you are driving, you need to get to a safe location, park your vehicle, and turn off your engine, put your car in park, turn off your engine, and join the session. If you are driving and you have your headphones on, please as well get to a safe place, park, and turn off your engine, put your car in your park, and turn off your engine, and then so that you can focus properly on the presentation. Wherever you are, if you're in the house, ensure that you know your exits, you know your restrooms, and if you're in the public space, ensure that you don't go into the the ladies' gents or ladies' restroom, or the ladies going into the men's gent. So identify your closest exit, and if you're joining us with a headphone, wherever you are, please ensure you keep your noise level to a minimum, and as well mute until you are requested to mute or to unmute rather. So when the questions are going to be asked, we'll do that by a raise of hands. Thank God for this application. You can raise your hands and we can go ahead. So this is a very great time for us to meet our facilitator. Our facilitator is Mr. Felix Oluyemi, and he's a seasoned energy professional with over 15 years of experience spanning exploration, appraisal, development, and production in the oil and gas industry. He holds his first degree in geology from the University of Ado-Ekiti, a second degree in applied geophysics, and is currently pursuing an MSc in energy and energy business. Mr. Felix began his career in petrophysics before transitioning into seismic engineering interpretation, and currently works in asset evaluation and project supervision. His expertise includes asset appraisal, portfolio ranking, lead and prospect maturity, well spanning, and strategic field development. He has a strong focus on turning investment into cash efficiently. Felix brings a unique blend of technical depth and business acumen, helping organizations grow asset value and make informed investment decisions. His mission remains clear: to support businesses in achieving sustainable returns and longer-term success. Ladies and gentlemen, the facilitator for the Seismic-to-Well Tie application and common pitfall, Mr. Femi Oluyemi, Senior Geoscientist of Asharami Energy. Ladies and gentlemen, a round of applause. Let me see some love right there in the chat as our facilitator comes on air to come and take over this session. Ladies and gentlemen, I'm not seeing those emojis flying. I'm not seeing the thumbs up. Ladies and gentlemen, it's not easy. We are looking at end to end here. I mean, his profile says it all. End to end. I mean, it's not easy. It's not easy. Please, a round of applause for him. Mr. Felix, if you are around, please say something to our beautiful audience. They are craving for your voice right now.
Thank you so much, everyone. Confirm if you can hear me clearly, please.
Yes, sir. Yes, sir. On my end, you are loud and clear.
That's fine. I want to say big thanks for this opportunity. I don't believe anybody is there to come and teach anybody. I believe we are here to learn together. So it's an avenue for us to share knowledge. It's an avenue for us to develop ourselves together. I used to warn the daddies in front of me that if they refuse to give us this knowledge, we will come to their grave and harvest their head and remove the knowledge. We don't allow people to take knowledge into the grave because it will be useless down there. Let's transfer this knowledge while we are alive, when we can appreciate each other. There's this one that says, appreciate me when I see they around, just on a lighter mood. So on this, I want to say big thanks to people coordinating this. This is wonderful. I was watching the number from when we were like 6 into when it turns to 25 to 30, now it's at 71. This is amazing. Amazing. Can we please put hands together for the coordinator of this particular YP technical presentation? They've been doing very, very great. They've been doing very, very great. To the moderators, you are in control. So if you want to push me out of this meeting, you have that liberty. But we just beg that we're doing this together. So we'll be presenting this together. Having said that, I think I want to share my screen so we can just quickly move straight to the presentation. If that is fine by my Oga moderator at the top.
Yes. My boss has said it. Ladies and gentlemen, I give to you Mr. Felix Oluyemi. You have the floor now, sir.
All right, that's fine. Okay, I'm sure we can all see the screen now, right? Hello, can we see the screen?
Yes, I can see your screen. Yes, go ahead, sir.
Okay, let me put
Yes,
it on
we can see your screen, sir.
Okay. All right, so we'll just be looking into one of the major aspect of seismic interpretation, It's a link between when you've loaded your seismic data or your data, then before you actually kickstart your horizon interpretation or structural interpretation. Without this link, yes, you can go ahead, but you might just be doing garbage in, garbage out. It's linking to a lot of things which we might not be able to discuss today. Not just for structural interpretation, not just for getting your depth map, it equally affects your GRV. I will try to explain that towards the end of this presentation. Again, it's a fractional part into what we call AVO, seismic inversion, and so on and so forth. So it's good to have this understanding from the scratch. It's very, very important, and I will want us to keep it very simple. So we are not just don't let us crack brain. Don't let us look too big into where the textbooks were. Let's just keep it simple. Let's understand the basics. What are we doing? Why are we having this? Why are we even doing this? What is the importance of doing this? If you don't do it, what do we stand to lose? And so on and so forth. So we just be looking at the presentation like we have preamble, the introduction to oil and gas business and description of seismic-to-well tie, resource requirements, then workflow and methodology, common pitfall and case studies. Then our guy said we need to do quiz. So that is who wants to be a millionaire section. We'll get who want to be a millionaire section after the end of this class. So that being said, so this is oil and gas value chain. Most of us currently, and I'm sure we are in the first part, which we call upstream and upstream E&P. And if you can see, that upstream actually start from exploration into production, then into production. Then what we are looking at today is seismic interpretation, which is. Please let us unmute so that we'll not be interfering. All right, then so we have seismic interpretation, which is a critical part of exploration part. Then again, we have the midstream and the downstream. So I just put this here for us to say that you might start with upstream, but at some point, I believe we're all becoming managers, we're all becoming asset managers, exploration manager, production manager. You need to understand the flow so that we can appreciate what each and every of these streams doing in the oil and gas business. So again, you can see I just carve out a particular place under the typical seismic interpretation workflow. So the workflow is just this simple: data loading, well log correlation, you've done your bastard correlation, you've done everything. At times you would have done your fault mapping before you do your seismic-to-well tie. There is no law that said that is not possible. But it's important before you get into your horizon interpretation to have tied what we call geology plus geophysics. So that is what the seismic. So this is just the space seismic interpretation hold. Some people will call it synthetic seismograph generation, or some people will call it seismic-to-well tie. So this is the space it sits, and in the typical seismic interpretation workflow. So I just put this one there. Sorry, the picture on the right is not very clear. I don't want us to focus on that picture because from the theory, from the past, it's like people see pictures more than see the letters. So let's just look into the letters. What is seismic-to-well tie? One, it's a process, right? Seismic-to-well tie is a process. What do you do in that process? One, you your seismic-to-well data log. So you have data from seismic, you have data from log. You want to combine the two to actually see, to improve your seismic and subsurface interpretation and analysis. Then it helps you to understand the relation between your seismic reflection and subsurface geological feature. We are going to be dealing with that. Maybe I will just elucidate or speak more on that when we get to what do we call case studies. So the processing helps in interpreting seismic data by relating seismic event to geological event markers identified on log. So you'll be identifying some major events on your log, which is your geology, and you now try to tie it to seismic. Okay, I think we have a place where I can quickly explain why we're doing this. So let's just quickly move because of our time. So what is the need for this process? Why are we struggling? Why are we doing all this? Why are we worrying ourselves about this? As I've explained, it's a link between geology and seismic. Then it's refinement of your check shot or your size or your velocity function. Basically, when you have a field, especially when you have a well on that field, then you have something you call check shot. then it's a refinement to that section so that you know that what you are picking is the actual seismic event that should be mapped. Then it helps you in doing some calibration in seismic processing. I noticed some processing guys on this call. So again, when you are doing processing, they normally ask for, can I get your check shot? This check shot, is a seismic generated, is it synthetic generated check shot, or is it check shot originally? Then they do request for sonic log. So because there is always a link between geology and geophysics, and you need to tie that perfectly for any processing to be depth wise and correct. And again, it's used in estimating what is the wavelength of that particular seismic section. So you can use that one to use your wavelength. We'll discuss that in the process of this presentation. So we've been mentioning seismic well tie, we've been saying time and depth. So while seismic is crucial step in seismic interpretation, allows well data measured in unit of depth to be compared to seismic data measured in unit of time. So here you can see we have two pictures here. One is talking about the seismic in time unit, the other one is talking about the depth in log in depth unit. Then you can see some two dash lines driven along. So you need to understand what is the reference time elevation from your seismic and tie that one to the reference time elevation on your log. For example, if you are doing seismic-to-well tie, are you supposed to be using measured depth when you are doing generating that, or you should be using vertical depth, or you should be using vertical depth subsea? So these things are very key. And when you are using deviated well, what is the difference between deviated well and straight well when you are doing your seismic to well tie? These are very, very key because at some point you will need to generate something we call seismic trace. Are you generating it along your seismic section? Are you generating it just on top of your seismic section where you have your well? So all these areas we need to look into, which we believe we still speak to a little bit. These are just doing preambles. Again, what are the requirements? What are the data requirements or resources requirements? Number one, you need availability of good data, good log data. So at times, you might want your petrophysicist to quickly look into the logs you want to use for this seismic to well tie to help you do some correction as required on them before you deploy them into this seismogram generation. You need something we call estimation of suitable wavelength. So if you don't estimate your wavelength, if you don't generate your seismic trace, you will not see anything to compare your log weight or your synthetic weight, because synthetic is what you actually generate from log, while your seismic trace is what you extract from the seismic. And again, the interpreter experience is very key. You need to understand, why am I seeing this particular event on my seismic? What does it translate to? What should I be looking at in log to tie to this particular seismic on event? Why did the required data is just your sonic log, your density log? Those are the first two key major logs for your seismic to well tie. Then some other logs could be gamma ray, caliper log, and check shot is equally very, very key. So caliper and gamma ray are not really very required, but again, they are good for you to actually calibrate and actually bring some understanding to what you are doing when you begin to interpret some features on your log, your features on your seismic. Then disciplines, basically you require petrophysicists and geophysicists. Sorry here, I do not put geoscience because geoscience is combination of the two. So I've been asking myself, am I a geoscientist? Am I a geophysicist? Am I a geoscientist? So I would just, at times it can be confusing, but let's just keep it simple. It's basically for geophysicists to do seismic well time, but that does not rule out that geoscientists or geologists cannot do it. You see yourself multitasking, especially in this part of the world, in Nigeria. Then your seismic data is very key whenever you want to do seismic to well time. So let's just look at it. So we have seismic data, we have well data. So you have sample area and volume. So your seismic samples areas and volume, it samples bigger than what your well can see. While your well can just do sampling on a point data. For example, if I just let's leave oil and gas. Let's go to borehole. So if you drill your borehole for well, you can only see that formation within the wall of the borehole. But the question I might want to ask is that 2 meters away from that your bore, are you sure that formation is what you encounter? If you go to drill 2 meters away from that bore, you are not too sure. You know, these things are very key for you to understand, okay, if this is my best aquifer, what is the volume of this aquifer? What is the lateral extent of this aquifer? So just the same thing is what we do when we are doing seismic-to-well tie, where we tie well to seismic. So then again, in terms of frequency, the frequency of seismic is very, very low compared to the frequency of well. So we can see we are now using one to balance the other, and that is very key when you now want to do your seismic wavelength extraction. You need to go and check something to know what frequency am I going to use to extract this particular seismic, such that you can bring your seismic and your well data into the same frequency. That is very key. So that is a negative on the seismic data. But again, let's look at the next step, which is the vertical resolution. So your vertical resolution for your seismic, you can see as much as 50 to 100 meters for seismic, but for your well actually do a refined vertical resolution. It can distinguish between your sand and shale very clearly. Where you have limestone, it will differentiate between your limestone because you will see them, especially if you have a log that are very good, or if you have core, or if you have sample that you've taken. However, when we talk of horizontal resolution, then again, seismic is taking lead there. So your seismic can give you a wider range of resolution, while your log can only give you few centimeters to meters on the vertical resolution. So measurement seismic measures amplitude, phase, continuity, horizontal. So let's just leave that part. While your web measures something like density, velocity, resistivity, radioactivity, rock and fluid properties. So these are just the comparison between seismic-to-well tie, and this is why it's good to understand this, so that when you are bringing them together, you bring everybody to the same stage. So where they have differences, you try to align them so that every one of them will be on the same frequency. I will just glance through this. I think I've explained this. So I will just, again, let's leave the picture. Let's just look at the ratings. So synthetic seismogram is, you basically need your sonic and your density log to generate synthetic seismogram. Then one thing you need to do, you need to extract wavelength. So wavelength extraction is from seismic, which are used in seismic inversion. So you can, again, from your seismic-to-well tie, move straight into something called seismic inversion. And after you've extracted your wavelength and you've generated your synthetic, the next thing to do is comparison and matching. So you now need to start comparing your seismic, your synthetics with your seismic trace. Again, I've said synthetic is what you generated from your well log, while your seismic trace is what you extracted, if you can. So I'm using generation and I'm using extraction. So synthetic is what you generate from your density and sonic log, putting one or two things together to, she's going to see that one in the course of this presentation. But for your seismic, because it's already processed, so you extract from the seismic cube or seismic volume that you have, then you play them side to side. Then after that one, then you now do something you call time to depth adjustment, which is where you now do your box shifting, your stretch and skews where necessary. Then again, we're still going to be covering some part of that in this presentation. Okay, now let's go to the understanding of gamma ray, sonic log, and density. So basically, your gamma ray is telling you the lithology, is telling you where you have your shale, it's telling you where you have your sand, it's telling you where you have your limestone, it's telling you where you have some other rock types that might be. I think we've seen a way that we are drilling, and we begin to see pyrite. So you might not be able to pick that one directly from your normal gamma ray, but other logs can support that. Then again, while drilling, when you are looking at the drilling ratio, when you're looking at the drilling rate, then you might be able to be saying that. But don't let us go much into that. Then your sonic is very good. So your sonic is telling you whether that particular velocity at that place is fast or that particular velocity is slow. While your density is telling you about how dense is this particular formation. This one is denser, the other one is not denser. So your sonic and density can come from block. But if you go back to processing, you will know that this is very similar to what you do, sorry, for your seismic acquisition. This is very similar to what you do in a seismic acquisition. You say you want to have your reflection from a particular horizon. What is causing that reflection? Because from one formation to the other formation, you have differential in your density and what, and your velocity, and that is what is causing reflection. And that is what you measure when you do seismic-to-well tie. So that is the link between seismic and well, and that is why we can actually do this seismic-to-well tie without any issue that, okay, we are not doing something wrong. Then looking into the far right, you can see we put something soft and hard. So for here, don't think about sand and shale. I think it's been proven that after a particular depth, your sand can become a hard, soft surface, while your shale can become a soft surface. But hard and soft, let's just look into acoustic impedance. So when your acoustic impedance is negative or is very low, then you term that one to be a soft kick. But when your acoustic impedance is very high, then you term that one to be a hard kick. Again, what is acoustic impedance? It's just a product of your velocity and your density. Then that is what you now convolve with your something we call extracted wavelength to get something we call reflection coefficients. So in reflection coefficient, again, don't bother yourself too much about this. Before you do any work, ask the processing guys, do they process with normal seg Y or they process with anti-seg Y, so that you know the color for your soft, the color for your hard, and also things. So I've seen a data where the negative amplitude, they actually hard kicks. They shows the hard formation, while the positive amplitude shows soft formation, because they use what they process that data in anti-seg. So always ask this question, please. How do you process this data? Do you process this at a normal seg or anti-seg? It's very key, so that you don't mislead yourself by the time you get to interpretation section. Now let us look at this colorful picture. So we have lithology, we have shale, sand, then we have velocity. When you multiply your velocity with density, it's going to give you acoustic impedance. Now let us interpret this acoustic impedance. When the velocity is low and the density is low, by the time you multiply, you are going to get low acoustic impedance. When your velocity is high and your density is high, when you multiply the two, you are going to get what do you call it? High acoustic, acoustic impedance. Now, from acoustic impedance going to the reflection coefficient, if you are transiting from your high acoustic impedance to low acoustic impedance, you are going to get a negative reflection coefficient. And that is where you have that your mark going to the left. But when you are moving from low acoustic impedance into high acoustic impedance, sorry, let me see if I can take my laser. Oh, okay. Fine. So when you are moving from this, again, I've told us it did not necessarily from shale to sand. So let's note that. But when you are moving from high acoustic impedance to this low acoustic impedance, what you are going to see on your reflection coefficient is negative. However, when you are moving from this low acoustic impedance into a high acoustic impedance, what you are going to see is a positive reflection coefficient. So this is very key, and you need to understand this. Now, when you now convolve this one with the extracted wavelength, then it's going to give you a wiggle, whether you have a low acoustic impedance, or whether you have a peak, or whether you have a trough. So basically, we've been interpreting trough as where you have your negative amplitude, and we've been interpreting peak as where you have your positive amplitude. So let's just take that for the purpose of this presentation. So this is the understanding we need to know about seismic-to-well tie before you proceed at all. So that by the time you are relating your synthetic seismogram to gamma ray, then to give you some geological meaning to what you've tied to your seismic, and it's very key. Where you have your gas, for example, where you have a gas cap, then you begin to say, okay, this gas cap should give me a low density. This gas cap, you expect your velocity to be low. So what am I expecting? The top of that gas cap should give me a soft kick. What is a soft kick? A soft kick is a negative reflection coefficient. When I get to seismic, what am I supposed to say? I'm supposed to see a trough. Simple. It's just that simple. I will want to pause to see Do we have a good understanding of this before we continue? And maybe the moderator can just answer that before we go. If you can just get a chorus answer. Are we all okay to this point before we continue? If you can get a chorus answer from everyone. All right.
It's okay.
All right. Thank you so much. So let's just continue. So what we've been seeing going forward are just the workflow methodology we've mentioned. So again, from this graph, we've already generated this on the right left. This is the initial synthetic seismogram, and so the blue one is the seismic trace, while the red one is the synthetic seismogram that we've generated again from this. So this is just a cartoon picture, but this is now the real stuff we are talking about. So from my right, you can see this is the blue one here. As I've said, is your okay. So they flip it here now. So the blue and this red one is your synthetic. While this one, the black one here, is your seismic. So we can see a perfect tie where you have your peak. Should tally with your peak by the time you do your box shifting or your stretch and squeeze on your seismic. So we can see from here now. Look at this place. I'm overing my cursor, laser, whatever. You can see that under this particular one, the blue one, you have a very broad, very strong peak. But on the red one, you have a very extended weak peak. But on the seismic, what do you have? You have extended weak peak. Now, the issue with this blue one here could be coming from when you are generating your synthetics, what frequency do you use? If you want to get it, if you start adjusting your frequency, maybe from 15 to 17 to 20, you might see yourself now getting something very close to what you be seeing on your seismic. Again, how do you determine this particular frequency? So there's something you call frequency spectrum. Regardless of the software you are using, there is a way you can get your frequency spectrum from your software. So you go to the frequency spectrum. When you display your frequency spectrum, it will give you like a dome shape from your amplitude and frequency. Then you can pick the maximum frequency from that dome shape. That is number one. Number two, or second one of getting it, you can go to your seismic session itself and count the number of peak between 1 second and take that one as the frequency of that particular data. And when you want to use your seismic, I would advise that you generate arbitrary line along the well bore. If your well bore, for example, is a deviated well bore, generate arbitrary line, digitize arbitrary line along that well bore and do your counting. So what is important here is that once you first of all display your frequency spectrum and you do your counting, compare and see what is the relationship, how different do you have the value you get from your counting on the seismic and to your frequency spectrum frequency, dominant frequency. They are not supposed to be far apart. They may not be exactly the same because from your spectrum, you have a global frequency. So it's like you are aggregating 10,000 different outcomes to get an average. And where you pick just one outcome, so they may not be exactly the same, but they should be similar. Your average and your representative, they should be similar if there's a symmetric relationship between your data output. So that's very, very key. So going back to my left, now, so the first thing they've done is they've now done some selection window. So, some software you can do auto correlation between your seismic and your synthetics, and will give you a value. Then again, you can do that. But again, if you now want to finalize your time, you might need to do some manual adjustments in your Seismic-to-Well Tie. And that is what this third one is now giving to us. Then if you check something we call correction coefficient, you can see when you first of all generate without any adjustment, you have something that is around minus 0.34. This is not very good. You have something that is giving you 0.25. But by the time you do your final one, you now have a correlation coefficient of 0.8. I will not lie to you. If you get this 0.8, I might start questioning and query your Synthetics-to-Well Tie because this figure is very high. It's difficult to get this high figure because there are still a lot of pitfalls, which we are going to be discussing at the later part of this presentation, but part of it is one, there is something we call processing error when your seismic data was processed. There is something we call acquisition error when your acquisition data or seismic was acquired. There is something we call acquisition error in your well log. There is something we call processing error in your well log. There is something we call instrument error in the software you use. There is something we call human error in the interpreter that is working. Combining all these 6 errors together, it is difficult for you to get a correlation coefficient on your seismic of 0.8. If I get something like 0.5, 0.4, I think it's always very good. If you get 0.8, we will not penalize you, but we might just be looking at you with one can eye that, okay, hope you are not just tying everything, just tying all the loops to each other, which I'm still going to explain in the course of this presentation. So methodology and workflow, we can see this is one of the work I did some years back. So I actually started from the gamma ray. I want to understand what is my gamma ray. From my gamma ray, I display my sonic log. I display my density log. Then from that one, okay, this is gamma ray. So these are the density, sonic, everything that we need to do. Then I generated my synthetic. Then some software will give you anti-synthetics. Then in between is where we have the seismic trace. Now, looking at this seismic trace in between and this particular one, so these are the two we'll be looking at. You can see you will not be able to tie. Let's just be looking at the peak to peak where you have black to black. Like this one now, if anybody is asking me.
Hello, sorry, sir. I don't know if your screen have changed because I'm still in slide 13.
Oh, we should be on slide 14 now. We're on slide 14. Where we have seismic section on the right and a seismogram on the left.
It's just slide 13, just changed now.
Oh, it just okay. Maybe there's a lag. Okay, so okay. Well, I'm not driving, but I'm inside the vehicle, so you know, network is still very wonderful in Nigeria. So there might be a little lag. Please, once I change the slide, I will speak and confirm if the slide has changed on your end before I continue. Okay, so let's look at this particular place. I'm hovering my cursor. You can see there are a lot of peaks. You can see here that from your synthetics, you can't really see them. Again, where is your area of interest? If you look at this top here, this is where I have my formation tops. Around this area, this is where I have my formation tops. I don't have any formation tops in Benin formation. So the question I usually ask people is that if you focus your time on tying your geology to seismic in Benin formation, I'll be asking you, what do you want to achieve from that? So again, because of that, you might not really focus majorly on this place. If you look at what I've done here, I tied this particular one to this. You can see a perfect tie between this peak and this peak. The next peak here, I cannot even see it on my well or my synthetic, so I don't bother myself. I'll just go to another. Where can I see another major peak? I can see another major peak, this to this. I can see this to this. I tie this. Then I can see this to this. I tie this. I tie this. I tie this. I tie this one. So in between, I will not want to be doing stretch and squeeze to ensure that each peak tied to each peak. That one is good on a pictorial view, but you would have destroyed the geology of that particular formation, especially your interval velocity. By the time you want to tie all the peaks on your seismic to all the peaks on your synthetics, and you have done something major to your interval velocity, you've destroyed the interval velocity, your average velocity. In fact, so by the time you not plot your velocity, whatever, you'll be seeing some distorted velocity because you are now forcing everything to tie. Again, in life is not that simple. That is, you are not expected to tie everything. Just pick the major event. For example, if you get your major shale where you have your high peak, or your major sand where you have your very low soft peak, reflection, just tie those two. All the in between, leave them, so that because what you do at times you might be just tying your average velocity, or for your depth to time to depth, you might be using your average velocity. So don't major on tie all the peaks to all the peaks. Pick the major ones you want to tie and tie them, and we go. Then Once you finish your seismic-to-well tie, you generate arbitrary line along all the wells. As you can see on this particular right, you can see the brown color now along the well is my synthetics. I now display it on the seismic and I bounce check, okay, where I have black on the seismic, I'm expected to have peak on them. Can we see that relationship? Yes, we can see the relationship here. We can see the relationship here. Importantly, we can see that relationship along all the 5 wells on this seismic. Where people get it wrong again is when they don't digitize that seismic line on the well. So if you digitize it some distance away from your well, then you will be doing something we call shadow time because you are not exactly on your well, on where your well is on your seismic. Again, let me quickly mention this. When you have 3 types of seismic data, your near data, you have your far, and you have your mid. It is important to do your seismic-to-well tie on your near data. That is the data that is closest to what? To your acquisition point, to your receiver. So because your well is closer to the acquisition point during the acquisition of well, then you should go to where you have the closest seismic event to your receiver, which are geophones during seismic acquisition. So it's always important. I made that error in my first 5 years. I used to tie with either full data board. The day I had a job with mobile, and the guy told me he's been doing seismic-to-well tie for the past 35 years. The first thing he told me was always tie with the near seismic stack, not the mid and not the far. So let me just quickly drop that. So from here, what are the, so these are just the way to do seismic-to-well tie. Maybe by the time we get to maybe about the slide 17, they will just be looking at some examples and we'll now discuss that. So again, what are the benefits of seismic-to-well tie? I've mentioned the upper part, so I will not even deal with that one. Okay, I've changed to slide 15. Are we all on slide 15 now?
No,
No,
not
sir.
yet.
No, sir.
Not yet.
Okay, so once we get to slide 15, just let me know so that.
Okay, we are
So,
here.
Well, 15
okay,
now.
all right, that's fine. So I've explained the first 3 bullet points, so don't let us go to that. Now let us go to understanding your seismic-to-well tie. So when you are doing seismic-to-well tie, what you are doing is, 1, you are telling the interpreter that pointing him to the horizon you are going to map. That importantly we need to know. Number 2, you are going to affect that person by the time that person does something called amplitude extraction, because if you are supposed to map horizon at time 2.2 and you do your tie and your tie push that horizon to time 2.5, the person will extract amplitude on time 2.5 and you've misled that guy in terms of amplitude extraction. When he's talked to well drilling, by the time they'll be prognosing the well to drill, and by the time they'll be prognosing the depth for completion, you will be misleading that guy. Instead of them to be thinking of the reservoir of interest is at 9,000, for example. If you don't do your seismic-to-well tie, they might be looking at 8,000. That is like 8,000 difference. Then again, when you are now talking of GRV, I don't know if I can, let me quickly draw something here so that we can have this understanding on the GRV. And this is very key. So let's assume this is my fault. Let's assume this is my fault. And this is horizon number 1. Or this is event number 1 on your seismic. And this is event number 2. So let's
Sorry,
just use
sir. I don't know if it's just me. I can't see what you're showing.
Okay, I'll put it back on slide mode. Okay. Can we see this? I just drew something now. Can we see them? Can we see where my cursor is now?
Yes, sir, we are
Yes,
seeing.
sir.
Okay, so this event is like a 4-way closure. So if I remove this fault, hydrocarbon can still stay here because here you have a 4-way closure. But the next event is a fault dependent closure. If I remove this fault, the hydrocarbon that will be here would have migrated away. That's number one thing we need to know. Number two, by the time I draw a line, a straight line here, and I generate my GRV, I will have a bigger GRV from here than when I use this one and draw this line and I generate my GRV. What have we done? If from your Seismic-to-Well Tie, the event is supposed to be number one, and your tie pushes that event to be number two, you've created a problem that they will never discover, not until where that well, that feed is now going to something we call abandonment. How have you created that? Because your GRV is a major input into your volume calculation. So if, for example, I'm supposed to map this one, maybe I should be expecting a volume of about 30 million barrels. But my Seismic-to-Well Tie pushing me to go and map this one. Then that volume will give me 20 million barrels. Then every decision, FID decision, every completion, even number of wells to drill will be based on my volume. So instead of them to have planned for 5 wells to in this reservoir, they will plan for 3 wells. Instead of the possible, let's assume we apply 10% of a recovery factor. Instead of them to now say from 40 million, I can get 4 million barrels and transfer one into money, they will be calculating on your 20 million. I'll be thinking they are getting 2 million barrels. So you've affected a lot of things that might not be unraveled for life, except another person comes, retire that seismic and return it back to the source. Seismic-to-Well Tie is not just for you to show the horizon to map. It's equally important all through. So it's a decision that once you've taken it, it affected every other thing to the abandonment of that particular field. So I just want us to get this clearly. So when you are doing Seismic-to-Well Tie, please let us be as careful as possible. I'm on slide 16 now, which I call case study. Can somebody sees the next slide now?
No, sir.
No, sir. We are
Not yet.
Not yet.
check
Well,
it.
I think we need to leave this country to another country where we have better internet. or we need to turn some of the geologists to high tech so that all right,
Sir.
don't worry.
They are here, they are listening, sir.
We are getting there, don't worry. We are getting there. Okay, can we see it now?
No, sir.
Yes,
We are
sir.
still yet. We didn't see the light.
Okay, moderator, please, how are we doing about time? I'm sure I can't see time here because I'm presenting. How many more? I'm sure I've shot about 45 minutes.
We should be running up now, sir. Though we should be running up in 5-10 minutes.
Almost.
Okay. All right. So this synthetic. Okay, this synthetic seismogram is generated from petrol. So we don't have any excuse. I will show the one from petrol. I will show the one from Kingdom. So any software as taught that can do it is always very good. Then again, we can say this person actually color code the gamma ray. Why is he doing that one? So he wants to see what is my response when I have my sand to shale, when I have my shale to sand. And that will guide whatever he's doing. So the in between here is the synthetic generated, and just on the side here is what we call the seismic trace. Again, he quickly displayed that seismic trace on the seismic section, and you can see a very good tie, though not very it's not very visible, but you can see a very good tie. You can see red to red, but here around this area you see that it's difficult to tie because even on your seismic section, the event there is very chaotic. So when you have a chaotic event, please don't bother yourself. Just tie something around this area where you have a very good response of seismic. Tie this one where you have a very good response to seismic. Then you can come, tie this other one, tie the one in the middle, leave every other thing because you are going to be averaging your velocity at the end of the day. The next case study, this particular one is from Kingdom, which we call IHS. Again, this person tried to do, okay, he wants to understand what is trough, what is peak. Trough is when you have your reflection coefficient on the negative side.
We can't see your slide yet.
Oh, sorry. Again. All right, I'll just wait a minute or a few seconds.
Or maybe
I'm
you
on
can
slide 7.
maybe
I'm
you
on
can
slide
project.
17.
Maybe you can stop the projection and initiate it again, sir.
Okay.
Yes, sir.
Let me just quickly do that. Stop. Okay. Okay, can we see it now?
It's still coming up, sir.
Oh, God, save Nigeria.
Okay, it's still coming up. So
Are
far,
you
we
for
have
real?
so far we have 115 persons on the call.
The screen is blank.
Wow, that's interesting. Very, very interesting. Very, very interesting. Very, very interesting. So can we see the slide now?
Not yet, sir. So I think this is heavily network.
Wow.
Okay, let me see if there's anything I can do. Cyan was slide what, sir?
18. I've moved to 18 because of our time.
Okay.
18. Okay.
Slide 18 now.
Yeah, which
Are
is
we
on
there?
the case studies. I can see the case
Yes.
study.
Okay, so this slide, what I just want to show us is what to tie, nothing more. So there was no synthetic. So we can see event 1, 2, 3, 4, 5. Oh, some of us can still not see it.
Yeah, I think on my
Yes,
own
sir. Yes, sir.
end, I can see the
We're on
slides,
18 now.
but yeah, I
Can you
think
see
most
or you
of them
can't
are
see?
coming in now.
Okay,
That
can we
this
all
is the
see it
5
now?
reflections numbered 1 to 5.
Exactly. So
And
if
your slide is off.
18.
Can you see this?
Yes, I can see
Sir,
this
yes,
on my
sir.
own
Yes, sir.
end, which is yes, I can see this on my
Five
own. 5
reflections, number
reflections
1 to
numbered
5.
1 to 5. Yes.
All right, can we all see it now, please?
So Abioye, can you see this on your own end?
Yes, I can see. I'm the one sharing my screen now. If everybody can see it.
Okay.
But sir, can you see my
okay.
screen?
I
Yes,
cannot. Okay. I can see. Just go to number 18. That's all. I'm on number 18.
Yeah, I'm on number 18. Yes.
Yeah,
Okay.
this was the last slide. So, sir, can you see this?
Yes, I can see 18 now.
Okay. Let's go ahead.
Let's go ahead.
Okay,
Sir.
so you can see the number 1, 2, 3, 4, 5. So if my well is on this number 1, 2, 3, 4, 5, this is the event you are supposed to tie to your synthetics. Don't bother about where you have this chaotic event. There is no way you can tie that one. Again, but if you move to the right part where my cursor is just moving, if you move to towards this northeast, can you see this strong event in the middle, between 2 and 3? My cursor is just on it. I don't know if you can see the laser pen. So do you know that if your well is now here, do you notice that the number of events you want to tie has increased by 1? Because again, that event is not clear on the left, but you can see that reflection clearly on your right. So that is why when you are doing your seismic-to-well tie, always extract your seismic trace along the well bore, because you might be dealing with a lot of stratigraphy events where some events are clearer, reflection are clearer on this side, and it's not clear on the other side. Let's go to the next slide because of our time. Okay, so this one, we are just on common pitfall now. So what are the common pitfall? I can just be speaking this while we await the slide. So a key one is a mismatch in resolution of seismic data. So if there could be a mismatch between your resolution from your seismic-to-well tie, the recording time has a lower resolution than the well time. Until we've explained all this one. Additionally, you can see some distortion, so some migration. Again, you don't really, if you don't have a full understanding of the processing of that data, whether they do AGC, amplitude gain, whatever on your data, that might be an issue for us. Other common pitfall includes data quality. What is the quality of your data you are using? These are very key. I detailed some of them in the slide. I think the moderator can share the slides with you. There is nothing hidden there. So I have further slide that actually covers some other pitfall, which is just I call backup. So I just detailed them. Because of our time, I think I will just stop it at this point. Thank you for your time. And again, I want to thank everyone for this opportunity to share this knowledge together. Thank you, everyone. Over to you, Mr. Moderator.
Thank you very, very, very much, Mr. Felix. This is amazing, amazing, amazing work. Honestly, my books is loaded. I mean, I don't know if I'm the only one taking notes.
Please scan them and send them to me again so I can learn from it as well.
I'll do that. I'll do that. It's amazing. It's amazing what you've done here, honestly. Being able to integrate and also tie our point data with our extensive data, which is our seismic data and our well data. You've also told us about our resolution, which is what we are seeing to what we think we are seeing. Also the extensive nature of the seismic and also the thin nature of our wells. How do we go about making sure that the end product, which is to make some money based on our GRV volume, when we get based on our net volumes, when we have done all the processing and everything. You've also told us how important something as tying the horizons or the events to a particular velocity somewhere in a particular location, how it affects the end product. I mean, it's amazing how you merge the technical with the business. It's overwhelming. I know we have a lot of questions, and I know that some of us are here for the first time. I'm seeing someone asking some questions in the chat. I believe this is going to be a good time to take a few questions. And I'm very sure that some of us don't know that it's going to be a quiz after this, but I believe.
Okay, sorry, Mr. Moderator, I apologize. I want us to take the quiz first before we go to the Q&A.
Okay, so
that they can test their knowledge. They can test their knowledge as hot as it is now.
Okay.
Okay.
All right, guys, you've heard it. We're going to be having our quiz. So I want all of us to prepare our pen, our paper, put on your thinking cap. In fact, put on your assimilation cap. Because I mean, the last time, I think that was more like 2 months ago or so, I did this quiz. I know what I got out of it. So I'm actually a winner of something like this. So people can win from here. Apart from winning, you can learn. So what more? In fact, this is more like a way to seismic tie. You are tying your joy with some money in your pocket, as well as tying it with a lot of knowledge. So it's not easy. Please, a round of applause for our facilitator. A round of applause. Let me see that emoji while we set up our quiz. I am not leaving here until I start seeing emojis. Mr. Felix has done a whole lot. I mean, he has done a whole. If you go abroad to do this type of learning, you pay a whole lot of money, and NAPE is giving it to you on the platter of gold, or should I say on a platter of oil, because of we are oil business.
Yes, we are dealing with oil and gas. That's true. That's true.
So, you're not spending billions of dollars to drill your well here. NAPE has drilled it for you. Come here and produce. That is what NAPE is telling you. I mean, these emojis I'm seeing is not enough for what our senior geoscientist from Asharami Energy has done.
I'm sure people are preparing the pen and paper for the quiz.
They don't even know. They don't know yet. They don't know yet. I believe they are all looking forward to getting some knowledge. Apart from getting some knowledge, they are also willing to show that, yes, Nigerians, NAPE in general are brilliant mindsets. So, I mean, our ideas find oil. So who better more, or who is at the right opportunity, or who has the right opportunity to be here? Yeah, Nape. Nape is doing it. Nape is doing it. And we are going to show them that, yes, we are also good learners. We're not just also good listeners, we're also good learners. Stabio, how are we doing with the quiz setup?
All right. Thank you very much, moderator. Thank you very much. Okay, can you hear me?
Yes.
Yes, I can hear you
clearly.
Oh, okay.
Yeah,
So
I can
thank
hear you
you
on
very
this end.
much. Thank you very much. So, yeah. So, for those who are just joining, you're welcome. It's been awesome time. So we're going to the quiz now. So the way it is done, we'll go question by question, and once the first question come up, it comes with the 4 options. Then the next slide after a few minutes, or let me say a few seconds, like some 5, 10 seconds, we go to the next page that has both the question and the answer. You understand? So what you do is that you put in your answer, maybe A, B, or C, or D. You put them on the charts. You understand? You put them on the chart. So if you know you are not using the right name on this account, please make sure you do that correction now. I don't want to be seeing Techno and 1640 something. You understand? We can't identify you that way. You understand?
I think I can also see the African giant there.
Please. So please use the right name so we can identify you, because once we pick you or you're a winner and we can identify you, there's no way we're going to send you money that we don't know that you're the one. You understand? So just please do that right now if you know that you're not using the right
let them
name.
include the number as well. Number 1,
Okay.
E, number 2, F, in that format.
Yeah, you understand. So number 1, A, number 2, like that. So while we do that, then we close up on that. Then we go to the next question. We close up on that, go to the next question, like that. Are you with me? So I'm still deciding, or we're still deciding if we should share the result or the winner here or the usual way on social media. So you can always go and check there and all that. Between now and Wednesday, you'll surely see it there who the winners are.
Amazing. I think I like that build up of anticipation.
Yeah, so I'll get into it. Mr. Sheon, can I go ahead?
Yes, please, you can go on.
Sorry, just a question. Can I take part in the quiz as well?
Who is asking?
I was beginning to even ask also. Maybe I should also take part myself.
Who is asking?
Wow.
So all right. So let's go ahead now. Question 1.
Amazing. The answers are coming up. What is the primary purpose of a seismic-to-well tie? Okay. This is interesting. Wow. A lot of A's, eh?
So now the answer.
Yep. There you go, guys. That is it. I think we have 100% A on this first question.
So we're going back with the first person. Next question now, we're coming up. Question 2.
So question 2 is up. What types of well logs are typically used in the seismic-to-well tie? Is it the resistivity for travel time? Is it the sonic log for travel time? Is it the sonic log or is it the gamma ray log? Maybe it's the neutron log. Who knows? Wow. It's clear. It's clear.
And the answer now.
Drum rolls. Oh, yes. Interesting. Someone is saying I can't hear the questions, though.
Please read it, too.
Please read. Please read. We can also help. I can also help with that reading the questions, but don't wait for my voice. I wouldn't want to distract you.
So we're going to question 3 now.
So question 3, what are some common methods for correlating seismic reflections with well data? What are some common methods for correlating seismic reflection with well data? Smart people. I'm not even done reading the question. The answers are flying. Please, what is the processor speed of their system? Because it seems my own is lagging.
And that's the answer.
Here you go. Visual inspection for question number 3. Amazing, guys. Amazing.
And we're going to question number 4 now. And here is the answer. And we're going to question number 5 now. If you can hear me, you can see my screen. Mr. Buchi, can you hear me? Can you see my screen?
Yes, I can hear you and I can see your screen. Sorry, I dropped off to answer a call. Sorry about that, guys. What is the role of seismic attribute in well to seismic tie? That's question number 5. Does it help in fault mapping? Your answer is here.
And the answer.
The role it plays in seismic-to-well tie is that, such as instantaneous frequency and amplitude, it can be used to identify and correlate geological features.
And next question, we go. 6.
Number 6, how can you classify gamma ray log in your synthetic seismogram? I'm very sure Mr. Felix spoke a lot on this.
And here's our answer.
Our answers are coming up. Good to have to add more understanding to your geology to geophysics correlation.
Next question, 7.
Number 7 is up and running, guys. Great
and here
answers.
we have our answer.
Visual inspection, automated correlation algorithms, and statistical method. Those are the significance of a calibrated time-to-depth relationship for seismic interpretation.
And our next question, 8.
Number 8, what is the ghost effect in seismic data and how can it be mitigated?
And our answer.
It causes reflection from the sea surfaces, guys. And I hope we're getting this as fast as we are bringing it up.
Then number 9.
Here you go, number 9. Product of density and velocity is called what? What was it? Who knows? Amazing, amazing. Nape for the win. Nape for president.
Then number 10.
Here we go, number 10. Entirely generated synthetic with extracted seismic trace. Which of the operation has major effect on the internal velocity of the formation? Entirely generated synthetic with extracted seismic trace. Which of the operation has major effect on the internal velocity?
And our answer.
Of the formation? Stretch and squeeze operations. Wow. It's amazing how stretch and squeeze can affect your interval velocity.
And that is the end of our quiz.
Congratulations, guys. A round of applause for yourselves. It's not easy, eh? It's not easy to prick your brain at this time of the hour when everything is hot. Amazing, amazing, amazing. A round of applause for everyone. You deserve a round of applause for yourself. A round of applause to our facilitator as well, to our publicity secretary for this opportunity, and for those people that selected these questions. You covered it all, beginning to the end. Amazing, 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 guys. Amazing.
All right. Thank you very much. Every question and answer came from our speaker today, Mr. Felix. So thank you very much, sir. And we can go ahead to the next thing, moderator.
Amazing, amazing how Mr. Felix has been able to cover the entire section, which is questions. And Napi did not disappoint. They answered accordingly. Amazing, amazing, amazing. So now we have our questions and answers. Who has questions? Who has questions? Who has questions?
We have ends. We have ends raised up, so we can start by calling them as their ends, and whoever asks questions, you can put it in the chat box.
Okay, let me see. Okay, so we'll go with number 1. Ovie. Is that a Mr. or is it a Dr. Ovie? Please, can you unmute yourself and ask your question? Mr. Felix, I hope you're still here.
Can you hear
Yes,
me?
I'm with you.
Yes, sir.
Yes,
So
I
you can go
can
ahead by
hear you, sir.
introducing.
It's
You can
Dr.
go ahead by
Sorry, sir,
introducing yourself.
please
It's Dr.
introduce
Ovie from
yourselves.
Switzerland. Yeah.
Okay.
I joined this call very late, but I'm very pleased with what Mr. Felix has shown. And I was just wondering if you guys can bring him back actually for another class, which is going to be practical, okay? So you place him one on the marine data
Okay.
and one on the land data to do a seismic-well tie. And I'm very pleased with what I've seen so far. Thank you.
All right. I think moderator would be the coordinator of this event. Then we can find a way to make that happen.
Yeah,
it's not
thank you very much.
impossible.
All
Let me
right.
just answer that. It's not impossible. Thank you so much.
Okay.
Thank you.
It's not
Of course, we'll
impossible.
look
You
into
heard
it.
it.
Sorry, moderator. Sorry, PS. Can I just ask that I know Mr. Julius Adesu is on the call. Can you quickly take a comment
Okay, sure.
before we continue with those whose hands are raised? Apologies for that.
Definitely. Sorry to the audience as well. Why we'll take this.
Yeah,
Very important.
thank you.
Mr. Julius, are you there?
Yes, he's here. He's speaking. Go ahead.
Yeah, thank you, my YP lead. And then apologies because I have another session for 11:30, which I have to be out of it. I joined a bit late. Oga Felix, good job. Just to add to what you have said,
Thank you,
even
sir.
though I joined when you were talking about the common pitfall. In the industry, this has been a trend, and I want to start advocating for bad practices. Many young interpreters get data, they will display the well path on the seismic, post the top, and begin to interpret right there. It is bad thing to do. So when you look at the workflow in seismic interpretation, after you have defined your structural framework by mapping out those faults, the next thing is to generate what we call synthetic seismogram, which is your well to seismic tie. Just as Mr. Felix must have said, the whole essence of that is for you to see that the corresponding seismic event you want to interpret come from a particular geological formation top, and you are able to understand what is the impedance property or contrast happening at that top, and then you then need to know what polarity of data are you interpreting from your well. You'll be able to know whether you are going to get the correct thing, because at the end of the day, the volume will be impacted if you start wrongly. Secondly, another thing that I want to add is that in your well to seismic tie, your log information, if you are not a petrophysicist, ask the petrophysicist to give you a corrected tonic and density log for you to start the interpretation if you don't know how to do log conditioning. And also, Sheffield data is very important because that is the next thing to do for you to calibrate your sonic with your Sheffield. And you must have good reason why you are doing that calibration. And some calibration are done along, it will just flow with the well path. Some are done at the marker. So it's always good to have some markers, either bar markers or the well top as it is, because you expect that velocity will change at different marker. And then that gives you a good control of your time depth relationship. When you are done with the well to seismic tie, the time depth relationship needs to be applied immediately. Once you are done with your seismic to well tie, you need to then apply that generated TDR. This is allowable in Petra before you then say you want to go and interpret. Let's show the best practice and then we'll get things right. Thank you for the opportunity to add a voice to this. Thank you.
Thank
I'm
you
done.
very much, Mr. Julius Addition. Very, 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 very positive about his remarks. Honestly, it's amazing the amount of knowledge that we are pouring out here. Thank you very much again, Mr. Julius. Thank you very much, Mr. Felix. So I think we will take Roslyn Adizwa. Roslyn Adizwa with your question, please.
Good morning, everyone. Good morning, Mr. Felix. Thank you for the insightful class. I'm Roslyn Adizwa from Anchor Point Integrated. I'm a seismic interpreter, but I read geology, so I'm a bit confused with a lot of things going on here. So my first question is, you said the well to seismic tie affects, I have 3 questions, please. You said the well to seismic tie affects the GVR. Please, can you throw more light on it? Can you give like a detailed explanation on that? And does fault interpretation also come to play when it comes to the well to seismic tie? Then that's one. The second question is, does the well to seismic tie affect the horizon interpretation? Or do you just interpret, I don't know how to put this question now. Do you do the well to seismic tie with horizons that have a better resolution? I think that's what I want to say.
Okay.
Then the last question is, in a situation where there is no sonic log, how do you generate your synthetic? Because what we were told, if you use density to generate, it would take the log shape of the generated synthetic will take the log shape of the density log, and sometimes it's not good. So is there any other approach to generating a synthetic? Thank you.
All right. Thank you, Madam Roslyn. Right. So starting from number 1, how does synthetic seismic-to-well tie affect your GRV? So basically in Niger Delta, the type of fault we normally have the major bounding fault are Lee-Street faults. So when you have your Lee-Street fault and you have sediment ponding onto that fault or rolling onto that fault, there's every tendency that in between, for the sake of this explanation, maybe 2.2 will give you a rolling into that fault, while somewhere around 2.4 will give you a rising into that fault. So there are 2 different things. A sediment or rising rolling into a Lee-Street fault, and a sediment or rising into a Lee-Street fault. There are 2 different things. So rolling into a Lee-Street fault, by the time you do your mapping, will give you a 4-way closure. Meaning, if you remove that fault, you might still have hydrocarbon there. But rising will give you a fault-dependent closure. So if you use the same thickness, the same depth, the same petrophysical analysis, and you calculate your GRV from if your event is unrolling at 2.2, or somebody mistakenly by seismic-to-well tie push that top to be on 2.4, then what your GRV will pick is rising onto a fault, and the GRV might be lower from the gross rock volume that you generate when you have rolling into a fault. So again, as I've said, this is part of this. This is a situation that we might not even know. We might so you might not know until so that's why it's part of why you now get some field will tell you that this field perform 120% in terms of production. So the extra 20%, where does it come from? For example, you've told me from the reservoir engineer told us that this field will produce 100 million barrels. We produce 100 million barrels and we are still producing until you get to 150 million barrels. So that remaining extra 50 comes from what? It all comes from the error, which seismic-to-well tie could be part of it if not clearly generated. That's question number one. Question number two, your rising interpretation should be done after you've done your seismic-to-well tie. And when you want to tie your rising as an event now, it is important you tie the major reflection, what you can see clearly, to your geology, not where you have something like chaotic event. If you are tying okay, let's go out of technical, let's go out of geology, geophysics, let's go to market. Or let's just use the example of when Jesus Christ said, "Who touched my garment?" What were the people saying? They're asking me, in the midst of all this everywhere, this most of this crowd, why are you asking who touched my garment? Somebody must have touched your garment. And it could be like 10 people touching that garment at the same time. But because Jesus Christ then tied the flow, because something left him to heal that person. So let's assume Jesus Christ is the well, is the real, the actual data. And the woman of issue of blood is the seismic. There was a flow. So he correlated that thing to that. So I'm sure so many other people touched Jesus Christ then. So that event, that clear event is that woman. That is the woman that was sick. That is the clear thing. Every other person around her, they were not sick, they were well. So the only thing you tie is the sick woman plus the flow of miracle from Jesus Christ. Every other thing around it is immaterial. And that is why if you read that part, they never mention any other person around that woman. It was only that woman that was mentioned with the flow. So just tie that clear event, that reflection you can see clearly on your seismic. That is what you should go and look for on your well log. Something must have given that clear event. There must be a change in formation or a change in velocity or a change in density or something. Look for that something on your well and tie the two. The other one, fault. So fault mapping does not really affect your synthetics. You could go ahead to map your fault before you even do your synthetic generation or vice versa. Whichever one it is, there's no effect on fault mapping. But you should note that if your event is tied to a geological, if your formation top is tied to a geological event on the downthrow side of the fault, but you get to the upthrow side, you should be looking for that event on the upthrow side a bit higher than where you tie in terms of time on the downthrow side of the fault. I hope that answers your questions, Madam Roslyn, right?
Yes, sir. There's a last question that you didn't answer. In an event where there is no sonic log
Okay,
and you
so
use your
yes.
density.
So for me, there is no one straight correct answer to this. Some people will tell you they will generate their sonic log from resistivity, but when I'll say Oga Sunday, I can't remember, Oga Julius said something that when you are generating it, you're actually supposed to give your log to a petrophysicist to do some correction. Part of these corrections are the fluid correction. So if you convert or you generated your sonic log from your resistivity, yes, you could use it, but there is a lot of uncertainties that you must capture in your report. I usually just go with density alone. I don't usually, or at times I will just do the two. I will generate with density alone. I will generate with getting my sonic from resistivity. and compare my result and look to my coefficient to see which one give me a high coefficient. So it's just like if you don't have your density, some people will generate density from gamma ray. But which all these things you are doing, you must know what is the physics basis between what you are generating. For example, why don't you generate that log from caliper log? Why don't you generate your sonic from caliper log? So we need to go back to the base theory to see what relationship do I have between my resistivity and my sonic? What is the depth of investigation of my resistivity and sonic? All these are very, very key. Which of the logs have a deeper depth of investigation? Which one is closer to the well bore? What is the effect of washout on the well bore? I would not want to go into, but so these are the areas you look into before you can actually decide, okay, or if that particular section, if you have like hydrocarbon in that resistivity, how do you correct from that hydrocarbon effect of hydrocarbon by the time you extract sonic from your resistivity? So it's a petrophysicist that you need to discuss with, and you guys will just agree on what you want to do. Always compare your result and capture uncertainties by the time you are doing your reporting on Seismic-to-Well Tie. Thank you very much.
Thank
Does
you,
that
sir. Thank
clear?
you so much,
All right.
sir.
All right.
Thank you, Roslyn, this well. I mean, it's clear. It's clear. So we understand that if you're not using your sonic log, what you are doing is that you are increasing the uncertainty within your interpretation. And as you're increasing your uncertainty, you're also increasing the output effects of the entire process. That's where your GRV comes in. Yes. And so in order for you to have a proper or rather a near accurate measure, from he said during the beginning of the class, the well is a point data. Your seismic is a vast data. So these data have been deposited over time and buried beneath, but some of them are clear. Those are stratigraphic markers. They are clear. So when you have those markers reflected on seismic and your well path intersects them, it is much more accurate or preferable that you tie your well along those markers. And that's why he made mention that if you have 5 stratas and you have 2 clearly defined ones, you should use those ones to tie your well so that you don't have so many ties, or rather some discontinuities in your ties. Because at the end of the day, what you're going to do is that if it's not so clear, you may end up trying to pick several points. Yeah, if you're picking several points, you're creating more uncertainties, and it's going to also affect your interval velocity. So I think Mr. Felix did an amazing job on answering that question. So we'll go to the next question.
Sorry, Madam Bushi.
Yes, please.
Hello, sorry, I'm still going to speak later, but can I just add something to what Mr. Felix said?
Okay, team lead, go ahead.
Thank you. I know we are not doing so well with time. Thank you very, very much, Mr. Felix, for doing justice to all the questions. But so another thing I want to say about the GRV that Roslyn talked about, if you don't have a good well to seismic tie, you are definitely not going to be interpreting the reflection you're supposed to be interpreting. And by doing that, by interpreting a wrong horizon, you are going to get a wrong GROV. So that is why Mr. Felix was saying that you should be very careful when you're doing squeeze and stretch. So for me, what I do is this. If I'm going to do maybe a box shift or squeeze and stretch, of course, there should be a limit to that. So once I'm done with doing all of that, I now try to compare the velocities from the original check shots, right? I plot depth against time of the original check shots and the velocities from the synthetic. So if they are not trending together, you know that I've tampered with this velocity too much. So you have to go back and, check your well to seismic tie again. Yeah, thank you. Go ahead, Madabushi.
Okay,
so sorry, before Madabuchi goes up, we don't have much time again, so we might not be able to take all the questions. So as much as we can, we'll maybe create an avenue where you can reach our speaker, or you can send your question to us. Then we'll get your answer back to you. So let's just speed up. Thank you, moderator. Go ahead.
Okay, thank you very much for all the amazing input. So let's make good of our time. Adedolapo, please go ahead with your question.
Good morning, everyone. Can you hear me?
Yes, you're loud
Yes,
and
I
clear.
can hear you,
Go ahead.
please.
Okay, good morning, everyone. My name is Awoni Adedolapo. And thank you, Mr. Felix, for this great and wonderful presentation and share. It was really knowledge-filled. So I have a question regarding QCing of our synthetic seismogram generated using the drift. So most times we have tiles, loops that we want to tiles together to our seismic. So at the point of that, we try to QC that using our interval, our input and output velocity. And some industry standard is the differences shouldn't be more than 9 to 10%. So when it comes to drift, taking our drift from the initial to the final drift after doing the stretch and squeezing, is there any industrial standard that says that, okay, at so percentage, it means you've over corrected or over tiled the well? So that's my first question. And my second question is, in case we have, for example, in case we have two wells on different fault block, and probably on the down throw side, we have a check shot. But for the up throw side, which the second wells drill through, we don't have a check shot. Can we actually share the check shot from the well on the down throw side to that of the up throw side? And also, what kind of percentage range of correlation should we like aim for in terms of our tiles, even though we are not using the actual check shot for that well? And also, the last one is regarding log conditioning.
Wow. So these are two good questions. Okay. So let me start from the second one. So I'm going to. So this is where experience comes in. Number one, let's assume you've done your fault mapping, right? Where you have your well. So let's work from known to an unknown. The downtown fault is known because a well there with check shot. Okay, so the first thing I would do is tie with the check shot on the downstream side of the fault. Tie everything, you have that. Then you need to copy that check shot to the on-throw side of the where you don't have the check shot. You just so subsurface is where whatever data is available, you have to come up with something. So you borrow that check shot, but mind you, the fault after a major boundary fault, or the velocity after a major boundary fault, you need to be careful. Accommodation created on the downstream side of that fault, you have more compaction, you have more sediment loading, so they may not be speaking to the same velocity. However, all you just need to do is pick 3 major events on the downstream side that you can still see on the upstream side of that fault. From that event, you can know what is the time shift, what is the time difference. So let's assume you have like a major marker on the downstream side at 2.0. You can see this might be possibly that marker on the upstream side at 1.8. You already know that you have a differential of 0.2, right? So by the time you are now doing your synthetic seismogram, you now copy that check shot. All you just need to do is that tie that particular marker, maybe 3 of them, just tie the 3 of them on the upstream side. Then by the time you are now doing your seismic interpretation, when you now cross your interpretation from the first one to the second one, or there's something we call a flattening. Where you tie this one, display your synthetic on seismic on the true side of the fault, then flatten that event to see. Flatten means you remove that fault as if that fault did not happen. Then you can now check those 3 major events to see how they tie correctly on the flatten. So you flatten on the first event, see how it flows, maybe few seconds, few milliseconds above and below it. If they tie very well, go to the next one, flatten at that particular event, see how it flows. They tie very well. Go to the third one, flat at that particular one, see how they tie. If they tie very well, then you can rely on that particular operation. Then again, you capture all this in your report. That is the only thing you can do. Now, to the first question, I don't usually agree on there must be a particular drift or no particular drift. So the question is, what are the input that you use? So if your check shot is derived from VSP, do you know some people, when they have VSP, they don't even do seismic-to-well tie? Because your VSP is like very accurate time to depth correction. Because of the way you acquire your VSP is quite different from the way you acquire your normal section. So if you have your VSP, I don't even expect to see up to 10% difference in your drift. So this drifting thing might be coming if you've not corrected for drifting in your sonic log. You know, I mentioned it at the beginning of the presentation. Mr. Julius again came in, and one of the good things he said was your petrophysicists need to correct your logs before you use them. And one of the reasons why we now do blending between check shot and your sonic before you now use that sonic to do your synthetic is to correct for that little bit of that drift. So the drifting usually error comes from your sonic log. If you've corrected all those things very well, we might not even be talking of what threshold, what interval, whatever, should it be up to 20%. If your seismic is very, very bad, you can get above 20%. If you are dealing with a stratigraphy event where chaotic event, just like talking of Okwama channel, for example, where you have so many things, rubbles running into each other, or maybe mobile that they, where they have like a rubble bed. What do you want to tie in rubble bed? So whatever you tie, your drifting might even be as high as 15 or more than 15. So people claiming that's an industry standard or benchmark, this is me, fairly speaking. I don't usually agree to that. I just trying to follow all the normal procedures in seismic-to-well tie. Whatever the result is, I check it and I present it and I QZ. So QZ, your size synthetic is part of what somebody mentioned. Go back to the original check shot, plot the two and see the trending. If the trending is opposite, then meaning you've done something wrong on your synthetic. You just have to go back because your check shot is not outrightly wrong. As I've mentioned, synthetic is just redefining or refining your check shot, not throwing your check shot away. I hope that answers your question, sir.
Yes, sir. Yes, sir. So it was good. It was perfect. Thank you.
Thank you very much. Thank you so
Thank
much.
you
Yes.
very much. Thank you very much, Mr. Adedolapa Awoni, for that amazing question. Thank you, Felix, for your response. Aurelio Atoja, you're next in line, please. Introduce yourself,
Okay, yeah.
unmute, and go ahead.
Thank you very much, Madubushi. So my name is Aurelio Atoja from Igensha. So I really want to extend my heartfelt appreciation to Mr. Felix because this presentation has actually given me some level of comfort in carrying out way to seismic tie workflow. So, but I have a couple of questions, a couple of questions, but I'm just trying to merge everything together based on what
Into one.
based on what you presented earlier. So let me just focus on two areas.
Are you asking the compound question then?
No, it's not a compound. It's not a compound question. So, okay, I will just focus on two areas because you've handled things on issue of data quality and the data gaps and the rest. So you speak to all those. Then, but what I want to get an understanding on is on extracting your wavelet from the seismic data. So you talked about determining the dominant frequency from your seismic data set, but I discovered that sometimes that actually varies across the survey, and sometimes when you limit the extraction of that wavelet to your volume of interest, you see that the dominant frequency there will be different from what you get for the entire seismic data. So what would you, I just want to get some steps, right? So what would you advise? So should I continue maybe to use the dominant frequency from the seismic data and use analytical wavelet for my wavelet extraction, or I should do a statistical wavelet extraction from my area of interest? Then so I have one other major question too, where I'm dealing with a legacy data that I don't have a any information about the acquisition and processing. Why I'm actually bringing this up is because you mentioned the seismic reference datum at the beginning of your presentation, and we know the other things like polarity and what have you that might actually affect the direction of your tie and interpretation. So what would you advise that one do in that scenario when you don't have any information about the acquisition or processing of the legacy data set? Right, so those would be my okay. So I'll just limit it to those two questions. Yeah.
All right, thank you very much. So again, I will start from the second question. So when you if you go to read processing report, you might even confuse yourself the more. So processing is it's a specialized job, and I give kudos to people that do processing. It's a specialized job. It's not something we don't study it anywhere in school. We only study the principle of that in school. So it is important if you can get the processing report to read, at least to understand one or two things about the seismic data you are using, as we've claimed is a legacy data. However, when in your seismic data, there's something called seismic loading parameters. So every software will show you where you can get some parameters, something called a episodic header. For example, you want to know what is your inline byte number, cross-line byte number, and so on and so forth. So in that same loading parameter information, you will see something about the acquisition time is 4 milliseconds. You will see something about the polarity of your seismic. So it's always very good to check that. So just don't go to just check your loading parameter from that basic data. Try to read everything. I think we normally have 3 headers. I can't remember the name of the last 2. Almost always check that. You will see some information about the polarity of your seismic. So, boy, if you don't get that, this is a dangerous one. If it is offshore, then you can go and look for something you call flat spot if you can see any. So basically, what is flat spot? Maybe where you have a gas cap, the base of your the contact between your gas and water should give you a peak.
Yes.
So if you can see that one, so maybe you have a structure. The top of that structure you have a peak. Then between that structure you have a top. Then you now have a flat black. What does that tell you? That tells you that your soft sediment in this particular data set is red, is a peak, is a trough. You can pick that information to answer that, but again, you need to be careful there because a lot of things can give you, in fact, processor can give you a flat spot.
Yes.
The processors, they can generate a flat spot for you. You go and drill it, and again, who will you arrest? They've done their job, they are left. So, but we need to be careful. So, but again, the area you can look to is that header, that's a data loading header. When you want to load your seismic, always check that episodic header and the remaining 2. They give some information there. That's one. So your question 1 on
wavelet extraction.
Wavelet extraction. Okay, fine. So thanks for asking that question. That will push me to add 1 or 2 things to this. So if your area of interest is from 2 milliseconds or 2 seconds, you can extract your seismic or your wavelength from that 2 seconds to 4 seconds, if that is your area of interest. Some software can give you that flexibility. So you might want to do that because, again, when you check your frequency spectrum is just averaging the total frequency of that data. So it's just giving you what is the dominant frequency spectrum, what is the minimum frequency spectrum, what is the maximum. It's not telling you the frequency of where your well is. We get now. So what I usually do is I would digitize a seismic session along the well bore. I will save that seismic as a line. I will now go to frequency spectrum and ask you, give me the frequency of this seismic line. So by so doing, you've limited yourself to that area of interest in terms of horizontal extent. Then if the software allow me flexibility to now put from 2 seconds to 4 seconds, I drop that one. But when I do that, by the time you now generate your check shot from synthetics, you will cut everything from 2 seconds above. Cut it, don't plot down. You are going to generate an equation. Generate your equation from 2 seconds to 4 seconds because that is the velocity you are dealing with. So if you if you don't do that, then the areas you not consider when you are doing your synthetic, if you now generate your velocity from 0 to 4 seconds, for example, you've added inherent error from 0 to 2 that you do not take care of in your synthetic into your velocity function. So I will just cut my time to that. So anything from 0 to 2 seconds, I will cut it off. I will generate my velocity function from 2 to 4 seconds. And then that means your horizon you're interpreting is between the window of 2 to 4 seconds. And that's what I would do. I hope that clarifies.
Yes, that's very clear. Yeah, thank you very much, and I'm glad that you're a fellow Kingdom user. So I'd like to admit you that
you are marketing that software, so the coordinators you pay to them for marketing the software. Yeah, all right.
All right.
Okay. We'll follow up on that. Okay, thank you very much. Thank you very much. So next, Halima Gajibo, please, before you go on, Abioye, how are we doing on time?
It's fast spent. Oh, it's fast spent. We'll have to stop question. Maybe just take one and let's go.
Okay, so Halima Gajibo, you'll be our last question asker, and
sorry, Mr. Sheon, I think the lead is here, so
Okay.
Mr. Sheon,
What do you think?
We don't want to lose people though.
Yes, so thank you, Abiya. Thank you, Madu Abuchi. I think what we can do is let every speaker ask their questions for 10 seconds. I see 6 people on the call. I have a feeling that some of the questions that they might have in mind to ask, I have a feeling that someone else might have asked it. I don't know if it's possible for Mr. Felix to just take everyone's question, the 6 people whose hands are raised. Let's just go straight to them. Please, 10 seconds. After 10 seconds, just respectfully, let's try and ask the questions within 10 seconds. Thank you. And Madu Abuchi, please help coordinate this. 10 seconds,
sure.
please. Let's just go straight to the questions.
All right. Thank you very much, lead. Mr. Felix, are you game? Can you take all questions at the same time? I think it has dropped to 4 questions now.
Yeah, that's fine. That's fine. That's very fine.
All right, we'll go in sequential order. Halima first, Kenichi second, Oluwajoba third, Bukola fourth. Please, 10 seconds, please. Thank you.
Okay, good morning. Thank you very much for this insightful session. I had quite a few questions, but I'll just ask the important ones. So having a diaper like in the same block, does it affect your seismic-to-well tie to the whole seismic? Then how
Sorry,
big is
having what? Shale
a
diaper, right?
diaper in your
Having
block,
a
but not
diaper in a
exactly
well
in
block.
that field, but in the same block, but in a nearby field.
If it affects the velocity, I mean, that's a question.
Yes.
Sorry, is it
Then
shale
also,
diapers she's referring to, right?
yes, shale diaper, sorry.
So shale
Okay.
diapers.
Then what's like the difference if you do seismic-to-well tie using check shots or versus if you have to use sonic log or density log? Then you said something about if you're doing your, I think, Z squeeze and stretch, and then you have a place that you don't have continuity, you should ignore that part. Is that what you're trying to see, or do you just continue down till how do you, if you have a very bad seismic, how do you actually account for that place that is not like continuously reflective?
Okay, so if I get your last question, you're asking if you are doing stretch and squeeze in a place that is chaotic, if it affects the entire seismic, right?
Yes.
Okay.
Yes,
So
and how do you go about it?
Okay, that's your question. All right, thank you very much. Mr. Felix, I think you got that one.
Yeah, that's
Kenichi.
clear. So we can go to the next person, please.
Okay, good morning. Thank you. Good afternoon, Mr. Felix. Thank you for the lesson. Okay, my question is about well log conditioning. So I remember you said something about how a very high correlation coefficient calls for a red flag and critic. on the level of tie. So I wanted to that immediately brought to my knowledge, my mind of a project I once did that had 80-something% correlation coefficient. So I wanted to ask well log correlation, because I remember I did something on I did the well logs using Hampson-Russell, using the log maths and A-log programs there, just to account for borehole irregularities, remove high frequency information from the well log, basically to condition it. And when I checked that with compared
Okay,
with
sorry, Kenichi. If I get to, you're trying to ask what is the correlation coefficient on well
yes,
conditioning?
how does well log conditioning affect correlation coefficient?
Crystal clear. All right.
Yeah,
So
that's
next
really
question.
That's clear.
Oluwajoba.
Right. Thank you very much. Good morning, everyone. Oh, sorry. Good afternoon. Good afternoon, Mr. Felix. I already put my question on the chat box, but I can just quickly reiterate. So my question is on phase, right? So given that maybe the PSDM final stack isn't zero phased, but it's minimum phased, maybe owing to like client demands or something. So what's the best practice for executing a well seismic tie in that situation? Do we have to get the data zero phased? Or if we're going to proceed to use minimum phase data, what should be done differently? What should we look out for? What should we ensure that we're going to do differently or pay attention to in that scenario? Yeah, thank you very much. That's my question.
Thank you so much. Nice one.
Okay, so I think Bukola, you're next. Or you have your
Okay, thank you so much, sir, for the opportunity. My question is quite similar to that of Kenichi, and this in respect to maximum correlation coefficient. I've worked with some clients who believe that if you don't have a high correlation coefficient, they don't have much confidence in that Seismic-to-Well tie, probably for some studies like power period prediction and the like. So what's the best what are other methods or what are other things that could be done to see your synthetic and Seismic-to-Well tie, such that it won't just be based on stretching and squeezing and just to have a higher correlation coefficient, thereby playing around with your internal velocities? Thank you so much. That's the question.
Okay, Mr. Felix, the floor is yours.
Okay. Good question. So when you have a shale diaper, number one thing you should know is that your velocity inside shale is not as the same thing as the velocity on the event that terminates at your shale diaper. So I don't even want you to bother yourself with what is inside that shale, except if somebody told you that you have opportunity inside that shale diaper. So, and you are not going to drill your well into a shale diaper, you are going to drill your well on the side to scoop the rising event into that shale. So let me simply put, the velocity are not going to be the same. If you don't worry too much of shale diaper, it's not going to affect your synthetic and seismography or Seismic-to-Well tie. So that's very clear. On the check shot, if you use check shot alone or sonic alone or density alone, you are not going to get the actual character you are supposed to see. So for seismic acquisition, what the energy see is a contrast between formation, and that contrast has been developed into velocity and density. So you need to have your velocity and density and check short for you to have a very good Seismic-to-Well tie. Anything short of that, your tie would not be as accurate as it should be. You can go ahead with it, but you should know that, in fact, if you don't have sonic and density, I don't expect you to have a very high correlation coefficient. So that is even linking to the next question that someone asked. Okay, we mentioned something about when you have a chaotic event. So when something is chaotic, when you want to do your Seismic-to-Well tie, you are tying something to something. So when you have a chaotic seismic event, there is nothing you can tie within that chaotic event. What I usually do is I will go to the top of that event, on your seismic, look at it in your synthetic. That chaotic event is just going to be seeing wiggles. There'll be no regular, but the top of it, if that chaotic event is harder than the event top of it, then you are going to see a soft kick, a trough. Just try the trough at the top of your seismic to the trough at the top of your synthetic on that chaotic event. Go to the base of that chaotic event, look for event that is continuous, tie it. Whatever that is happening inside that chaotic event, don't bother yourself. Anything you are trying to tie there, you are just it's not scientifically or geologically reasonable because it's a chaotic event. We say the event is not continuous. You cannot, if it's just like when you are mapping stratigraphy event, you are mapping this event, it goes to a place, it terminates. What do? You stop, you cannot continue. So if you jump to the next event, you are to jump to 50 events. Before you know it, you've mapped different 5, 6, 7 events, or you're thinking you're on the same event. So when you get to a chaotic environment, just tie the top and the base of that chaotic and leave it. Then what will do, you are now using average velocity within that chaotic event to do your depth conversion. How does long conditioning affect correlation? Of course, it will make it better. So once you condition your log before you do synthetic, it's going to give you close to high. For me, anything I've been tying for what I've been working, whenever it's 6 or 0.6, I will just be dancing up and down. But when you are seeing above 0.6, maybe you are not doing a textbook correlation coefficient seismic tie. That is, but there are a lot of inherent errors that we have on the seismic and log. So if you correct your log, do you know the correction that was done on your seismic? There are some things you don't have control over. But for me, when you can get up to 0.6, 0.7, I think any industry should allow that to fly. That is just that. But when you do your log conditioning very well, it corrects that. But when you now move into the seismic inversion space, there are some other correction that can be done on the seismic inversion to even quantify and to, what do I call it now, to refine your seismic to depth match again in seismic inversion. So that particular space, then your correlation coefficient cannot be going higher until you get to the AVO, which is another discussion entirely. When you have a phased seismic, or when your seismic are not zero phased, this is a very good question. So I would have loved to talk this question to a question, but when you have a zero phase, what do you expect? You expect your formation trough for a soft kick to be in the middle of your trough. But when you have a phase that is not zero, then you expect those things to be at zero crossing, either negative zero crossing or positive zero crossing. So all you just need to do is that once you understand whether this data is zero phased or not zero phased, where do you expect to see your formation top? Your formation top for zero phase data should be, if the top of your sand should be in the middle of the trough. Why, if it is not zero phase, you are expecting it to be at the zero crossing, whether from black to red or from red to black. That is all you need to do. You might not really want to phase or not doing phasing or doing your zero phase on your data. I don't think as a geoscientist, as a processing guy, has that total knowledge to do that. You might have been committing some other error on your seismic data that you did not see at that point in time because you're only focusing on synthetic, but you would have done one or two things into your seismic data that is already changing the geology of your particular formation. I think that answers all the questions. Thank you, everyone.
Amazing pitch by Mr. Felix Oliem. A round of applause for him, please. A round of applause. Let's appreciate him again. It's not easy. It's not easy. I mean, these are years of experiences put together all the way from petrophysics down to the geophysics, down to the business aspects. A round of applause. We really want to appreciate you, Mr. Felix. We're giving you a good thumbs up and a round of applause. In fact, I would have said some things here, but we'll talk about this later. It's amazing. Thank you very, very much for this opportunity of sharing.
You're welcome.
Thank you very much. Thank you. Mr. Bioye, I don't know. What's on the next slide? Can you switch the slides?
Okay. Right. Thank you very much. Thank you very much, everybody. So right now we'll be going into
Sarah B, before you go on,
closing remarks.
let me join the voice as well to thank to thank the speaker for today, our very own Mr. Felix. Thank you so much. I mean, there's no doubt
You're
that this
welcome,
has
sir.
been very insightful. There's been several things to learn from the question and answer, and then from the responses and the quiz as well. I want to say a big thank you to you. I mean, this for the session that you have given to us today. It's not been easy to try to get your time, but thank you so much for creating this time to share this knowledge with us. We are really, really, really grateful. And I know you are very passionate about the young professionals as well and the students.
Very.
Thank you so
Very,
much for
very.
doing this. We really appreciate it as well. Thank you. Thank you so much. And just to thank
Welcome.
everyone who participated today, whether during the question and answer segment, the quiz segment, and to everyone who listened and I even asked questions, thank you so much. I see several people on the call. Just to recognize some of our senior professionals that I had seen on the call, some of them have left. I see Mrs. Tino Labina. Thank you so much for being in this session. I see our General Secretary of NAPIA as well, Dr. Christopher Jackson. Thank you so much for being present here with us.
Oh, wow.
And I know that there are one or two others as well that I might have missed. I just want to use this opportunity to recognize each and every one of you. Thank you so much for joining us in this session. And I do hope that some of the learnings that we've gained today, we're also able to go back to our individual companies or wherever to put them into practice and then continue to find oil and gas. Thank you so much, everyone. Abioye, over to you.
All right, thank you very much, team lead. We can all see my screen, right?
Yes. The screens are very, very visible.
All right.
We're still on the agenda.
Okay, so now we'll move to the announcement. Yeah,
Okay.
announcement. Yeah, so as you all know, meet your ESCO. These are the YP ESCOs, for Mr. Shemun that just finished speaking, to Ms. Bethel Akuche, to Lighton, to Abel, General Secretary, to Uche Owali, which is Provost, and Daniel Abe, the Financial Secretary / Treasurer, and to myself, Abioye, Banjo Code Publicity Secretary. Nice to have you guys here today. Yeah, so we also want to celebrate one of us. Yesterday was our Financial Secretary's birthday, a person of Daniel Abe Daniel. So I know you guys must have seen the flyers all around and all that. We celebrate you, Daniel, and like we wrote, say cheers to numbers, balance, and the Mawu mix. It all add up, you understand? So thank you very much, the global Daniel Abe. Yeah. So you have to look out for the next technical meeting for July. You can tell that this was really awesome. We had over 120 persons online today. Really awesome. And I'm beginning to feel like we might actually have a practical section, something like that. I'm beginning to feel like that we will. Let's see what will happen. Yeah. So and few days back, we had a visit to the hydrography I mean the Navy, or what's it called, ship now. So at Apapa, they're about NNS Beecroft at Lagos. That's on Tuesday, 17th of June, for the 2025 World Hydrography Day. So we're with the Nigerian Navy, and we had great time. You'll be seeing some of the pictures displayed on your screen. So this was during registration. Yeah. Then sorry, some minutes. Yeah. So then we have just a picture slide showing people all around, some of the staffs there and the participants from different associations and schools. So can you see my screen?
Yes, we can see your screen.
Okay.
Beautiful
Okay,
hydrographic day.
Thank you very much. Thank you very much. So these, and we had a great time, you understand. So they took us around, their vessels, and all that. There was a particular vessel that was leaving like that day or a day after, for survey and all that. So they do survey also and all that. And thanks to them, they help us chart the navigation routes. Is one of the primary things they do. They help us chart the navigation routes for sailors or ships or vessels. You understand? That's not for explorations too. Yeah, so you can see that here. Yeah, so the particular ship that the main event actually happened was called Lana, like something like Odelano, something like Lano. So you call it Lana, but it's actually Lano. So Nigerian Navy ship Lano. So it's a surveying vessel and all that. But you also know that what it's surveying vessel for the military is totally military too, defensive and all that. Yeah, so these are some of our members, that were around to celebrate that day of learning and all that. So this is a photo session with the top officials of the ship. That's the ship captain at the center seated. Yeah, so then yeah, just to show a video of what we experience also. You can go ahead and just enjoy. Now, let me warn you, do not laugh. I repeat again, do not laugh.
Your mic is contacted, I attract clientele. But my check is hyper death breathing. Yeah, I excel, then prevail. Your mic is contacted, I attract clientele. But my check is hyper death breathing the sniper's breath. I excel. Ready?
Yeah, so that's it. So look out for the next event and join us. So yeah, our last series was a financial literacy series, oil money in digital age, leveraging digital wealth and tools. So now you can find the recording. It's already on YouTube. So you can find it on YouTube. Even this meeting we're having today, you'll find it on YouTube. After now, maybe anything from Tuesday, you find it on YouTube. So now then you check your app for the winners. We had 3 winners, major winners that day. So you can check your app already if you have not, because we've confirmed that the winners already have their what is it called, their payment, their reward received on the app. So 50,000 for first winner, about was it 30,000 for second or so, and like that. So please confirm if you have not. We have received about 2 confirmations or so. Yeah, so now here we have technical series coming up, NAPE technical series for Port Harcourt. We have it coming for Tuesday, 24th of June, this coming Tuesday, revitalizing old seismic land survey using CRS. That's a common reflection surface technology. So please, let's attend. You understand? These are things that people pay for to attend. Well, part of the perks or the gigs you get being a member of this association. So please, let's attend. And Bini chapter, you are if you know Bini chapter very well, you understand that technical series is always taking, different vibes and all that. So June technical series for Benin is coming up Thursday, also 26th of June, 11 a.m. So though online, but I also heard, though not publicized, that there's a physical location for those who are around, so you can reach out to the numbers there and all that if you know you'll be there physically. So, and another hint I got is that there's going to be like recharge for those who join, like massive recharge. I'm not joking when I'm telling you there's massive recharge. Now you have to know that there's massive recharge. So look out for this: unlocking values from legacy seismic data, reprocessing techniques, challenges, and achieve best practice. So part of the message I got for them is that logistics and all that, you should not worry. They got it figured for 400 people that are going to be joining. So if you join in and you're one of the winners, come on, you can imagine. So that's for that. Then for July also, we have Okaweri chapter having a glance into the structural evolution and hydrocarbon occurrence and distribution in parts of the Eastern Central Swamp Depot Belt Niger Delta. So on Thursday, 10th of July, 11 a.m. as well. This is both a physical and an online meeting. So please, if you are in Abakaliki, Ebonyi State, you can check in Serene Hotel Limited. So then for UAP series, so we had the first series, second series, and this is the third one. So from concepts to value, industry best practices in pre-drill and real-time pore pressure assessment for enhanced drilling safety and hydrocarbon recovery. So this is going to be this session is going to be taken by Dr. Livinus Nosike, managing consultant, integrated LV Service Limited. So please, these are part of the things that we want to attend, we want to learn about and all that. So then mini conference, the publicity has been on and all that. August, we are here already, August 28th to 30th August 2025. So if you're a student, this is a part of the conference that you have to attend. Is mainly, is when you say it's tailored for students. So tailored for students majorly. And if even though you're not a student, you're a professional, you're working already, you can still be there. You understand? And you can sponsor students too. Maybe you have a mentee that's in the university. You can tell them, have you seen this? Go and register for this, and all that. So here we have part of the highlights is InterVarsity quiz. You understand? The Varsity Geoscience Challenge Bowl, which is a quiz, and you can see the prize here: 200,000 naira for the first winner, 200,000 for second school winner, and the 100,000 for the third school winning that day. So if you are a school and you have not registered, please, you can register. You can see the registration link, and you can also follow on social media to get details of all this. So, and this is the major flyer. We've seen the registration: 15,000 for early bird, that's if you're a member; 20,000 non-member, professional 30,000 naira. So you see that now you are a NAPI YP, 30,000 naira for you. But after July 14, it moves to 40,000 naira. After July 14, non-NMGS or NAPI member is 30,000 naira. After July 14, members is going to be 20,000 naira for students. So we have free short courses that we're going on: software trainings, meets and greets, networking, keynote speeches, technical presentation, InterVarsity competition, like I've shown earlier, sports competition, and games. Then we have field trip. Man, you don't want to miss field trip. Field trip for mini conference has always been awesome. You can imagine having someone like profs and all that around, you're asking your question, they are giving you a response, real-time practical question in the field. You understand? Question that maybe you were not able to ask, all those things, you can see it practically on the field, and of course, it's going to be awesome time. So yeah, you can roll the bells and all that. NAPI is 50. It's a lot for us. It means a lot. We are 50. We are happy and we are big about this. We are doing this big. So come Thursday, 14th August 2025 at the hotel, we'll be celebrating our 50 years. And the theme for that day is pioneering the future of energy in Africa. So you can imagine. So we are big on this. You understand? NAPI is global, is big. So several event highlights for that day is that we're having presentations and panel section defining the energy landscape for the next 50 years. So you want to be there. You want to know what is being discussed. Looking ahead now, Now we are looking ahead. So we want to know what is being discussed, defining the energy landscape for the next 50 years. Then Golden Jubilee Gala Night and recognitions. Then NAPE Legacy documentary and historical timelines, 1975 to 2025. That's really long. Then commemorative magazine featuring retrospectives and visionary insights. So we want you to just plan this ahead. Registration flyer for this will be coming out. So I want you, immediately you see the flyer, just just click the link and quickly register. Because I tell you, you can imagine how many people will be coming in, and I'm very sure at some point registration will have to close. So please, this is like an hint ahead information. So we are honoring NAPE legacy, spotlighting the impact of Nigeria professional in the energy sector, and chart a visionary course for its future. So yeah, usually please pay your due. Pay your due. So if you have not paid your due, you have not updated your membership, please do that now. Do that now. So the membership officer number is going well now. You can call him, and his mail is on the screen, Mr. Daniel. You can reach out to him, or you can call him Mr. Mayowa, either one, Daniel Mayowa. So you can reach out to him. Student is 2,000 naira. Active member is 12,000 naira for updates. Associate member is 12,000 naira, and corporate member is 50,000 naira. So look at the value that is coming to the table. Look at all technical meetings and look at that just to update your membership. Come on. And please, let's do that. And meanwhile, for the main conference, which is coming up November, NAPE YP, we have the privilege of paying 50%. That's if you have active member, you are paying 50% of the money. Usually you're supposed to pay 100,000 naira, but for now you're paying 50,000. So I want us to just utilize this opportunity before it closes, or before we get the maximum number of how many people we can accommodate for this slash price. So thank you. So now, like I used to say, if you are not following us, please do follow us on social media and tag us when you are doing a celebration, you get a new job, tag us, we'll celebrate you. We'll come there, we'll comment, we'll appreciate you and all that. So follow us on, Facebook, follow us on YouTube, follow us on Instagram, on Twitter, follow us on LinkedIn. So you see us everywhere. And thank you very much for staying true to this time. And Mr. Sheon, if you're still on call, if you have anything you want to say, you can go ahead, please, and moderator can then go ahead. Thank you very much. I'm Abiyoye.
There you
Thanks,
have it from the
Abiyoye.
publicity
Thanks to our
secretary.
moderator as well. Thank you so much, Madabuchi. And you can give the last closing remark and then we'll end.
Okay, thank you for the honors. Like Mr. Femi to say one last thing before I round up. It's really a pleasure to have him here. Okay, I guess not. But then, thank you very, very much. You all heard it from the publicity secretary. It's not been easy. Time and energy came into picking out this event, following up with the facilitator, and the facilitator also coming in. And all NAPE is asking for you is for you to take your time and join this session. So please pay up your dues and try to connect as much as you can. So this is Madabuchi signing out on behalf of NAPE YP. Thank you very much. Lovely gents and gentlemen and ladies as well. Bye for now.
Thank you, everyone. Bye.